need to go back and watch one of our lessons. Okay, so should be good there. I'm going to move this down. I don't think it makes a difference. I'm going to move that down. All right, so today is August 18th. No, August 19th. So August 19th. And it's section P-1. All right, so again, some miscellaneous review topics here. All right, so for starters, I just want to review finding X and Y intercepts. We did that last year. Hopefully, you've got this to where I wouldn't even have to do it. You just know how to do this. So X and Y intercepts. So we're going to give you equations. Now the difference probably from last year to this year, the equations are going to be a little more complicated. It's not just going to be standard parabolas. All right, you might have equations either in function form or y equals. So this one's just going to be like, say, y equals x square root of 16 minus x squared. Okay, so we didn't really do a lot of weird, strange looking equations this year, but now we're going to introduce those, okay? The way you do it is the exact same way, okay? You've got to find x and y intercepts separately, okay? So you're going to go find those x intercepts first. What do we let equal 0 on an x intercept? Y. Okay, so y equals 0. All right, that just kind of helps you remember there. All right, so I'm going to take this equation. I'm going to replace y with 0. So 0 equals x square root of 16 minus x squared. All right, now I need to solve that. Now this is where you got it, like, see what I was talking about when we reviewed solving the other day? Like, no matter what the equation looks like, you've got to know how to solve it. All right, now on this one, I've got a product. I've got x being multiplied by that radical. All right, so I can use the zero product principle because this is set equal to 0. So if I multiply two things and it's set equal to 0, one of them has to be 0, right? So I can set each of them equal to 0 and solve and see what I get, okay? So if I set this one equal to 0, x equals 0. If I set this one equal to 0, square root of 16 minus x squared equals 0. All right, so first thing we're going to do, what? Square both sides. Okay, so square both sides. That'll leave me with a 16 minus x squared equals 0. I'm going to choose to move the x squared over just so I have less movement. So 16 equals x squared. So plus or minus 4? Square root of both sides. So x equals plus or minus 4. Okay, now if these are x intercepts, I could write this one as 0, 0. I could write this one as plus or minus 4, 0. All right, so we do want to write those as ordered pairs. Okay, now if I'm going to do y-intercepts, that would be the opposite of this. So that means I would have to let my x be 0. All right, this one may be a little bit easier here. So I'm going to go y equals. I'm going to replace each of these x's with 0. So 0 times the square root of 16 minus 0 squared. All right, well, you got to be able to do that real quick, right? 0 times anything is going to be 0. So y equals 0. So again, on that one, 0, 0. But we kind of knew that because this is an origin. So if it goes to the origin, it's the x-intercept, or x-intercept, yes, and y-intercept. Okay, but you want to make sure, since they're intercepts, that you are writing them as ordered pairs. All right, but the only reason, reviewing the overall concept of x and y intercepts of plugging in, 0, but then also kind of taking a look at some of these stranger equations that we've not worked with in the past. All right, and then again, it's going to be, can you solve that type of equation? Okay, let's take a look at testing for symmetry. All right, when we do curve sketching, if you run a test for symmetry, it might help you in the sketching. All right, we tested for symmetry last year. Test for symmetry. But last year in pre-calc, we did it algebraically, and you can do it algebraically with the rules that we did. What we did, we were testing for, this was last year. Okay, so last year. let's just summarize it so that, because I'm going to kind of show you a quicker way this time. Okay, so like last year, if we were testing for x-axis symmetry, what did we do? We took the y's and replaced them with negative y's, and then we checked to see if, you know, we could manipulate the equation and get back that original, right? You remember doing that? We did it quite a bit, but doing it that way, we had a lot of algebra to do real quickly to test for symmetry. All right, when we were testing for that y-axis symmetry, well, we took every x in the problem and we replaced it with that negative x, and then again we did the algebraically, you know, simplifying that to c. All right, and when we were testing for the origin, symmetry around the origin, we replaced both. Okay, so we replaced all of our x's with negative x, we replaced all of our y's with negative y. There's absolutely nothing wrong with doing it the exact same way we learned last year, okay? The only reason this year that you would want to do that is if we were in the curve sketching chapter and you just, you know, you were struggling a little bit with what your curve was going to look like, you could test for symmetry and then see if that would help you sketch it, okay? Now, if the curve is a polynomial, then we've got some shortcuts. Okay, but again, you would have to memorize the shortcuts if it's going to benefit you. All right, so this is a shortcut for polynomials. All right, this shortcut does not work for any other type of function. So if you've got a rational function, it's not going to work. Okay, you have to have a polynomial. All right, so 3 little rules here. It's going to be symmetric to the x-axis. All right, if all y's have even exponents. And you can kind of see the correlation there. What we did over here with our y, we plugged in negative y, so it's the opposite again. So if I'm testing for symmetry around the x-axis, I can take a look at all my y's and see if they have even exponents. Okay, and if you can answer yes to that question, it's symmetric to the x-axis. Okay, second rule for a shortcut here is symmetry to the y-axis. All right, if all, and you can probably guess here, it's going to be if all the x's have even exponents. Okay, then you know it's going to be symmetric to that y-axis. And then we want to check for symmetry around the origin. Okay, so for a shortcut here, if all x's and all y's have either I'm going to run out of room and have to go to another page anyway. Have either all even exponents or all odd exponents. Okay, so again, you can see the comparison to the rules we used last year and then these shortcuts. Okay, now I would like to have the rules on the piece of paper so we can see that as well as when we're trying some of these examples. Okay, so I'm going to throw an example in right here. So in other words, let's take a look at y squared equals x to the 5th minus 8x. Okay, so first of all, is it a polynomial curve? Yep, it's a polynomial curve. So that means I can apply my shortcuts. All right, so you might as well just start with one rule and then go all the way through. Okay, so if I want to test for x-axis, I'm going to look at my y's. Well, I only have one y, and it is even, so it does fit this. So it is symmetric around the x-axis. Okay, so I know that. All right, now if I want to test for symmetry around the y-axis, I'm going to check my x's out. I have 2 x's. Both the exponents are odd, so it's not symmetric around the y-axis. All right, and I've got even exponents and odd exponents, so it's not symmetric around the origin. Okay, so much, much faster than what we did algebraically last year, but there again, you have to have the rule memorized. If you don't have the rule memorized, it's not going to do you any good. Okay, so let's do, I don't know, let's do something like X, Y equals 8. Okay, so what do we got here? Ponder it for a minute. You're going to ponder it. I'm going to put it in the graphic calculator just real quick. All right, so you ponder. Ponder, ponder, ponder while I'm playing. Okay, so what do we think? Symmetric around the origin. Okay, now let's go ahead and write that. Now, I want to see how much you can think. All right, you got to think a lot this year. Can you graph that? Dane, can you talk loud enough to tell me how to graph it? And now you're doubting yourself. Don't doubt yourself. Yeah, it's going to be a rational function because what are you going to do? You're going to divide both sides by x? Yeah. If I take this original equation, I've got x, y equals 8. If I divide both sides by x, okay, I've got y equals 8 over x. Well, didn't we learn how to graph that last year? We had that one memorized, right? So if I sketch it, do a rough sketch, there it is, and it's symmetric around the origin. Okay, so you can also kind of apply what we know and just about sketching, just our rough sketching that we learned in pre-calc, and apply some of that kind of stuff. Okay, now let's throw in one more example right here. I'm trying to keep them all on the same piece of paper because I want you to be able to see the rules. All right, what if I had something like y equals x over x squared plus 1? Ponder it, think first. What am I trying to catch you on? Because I'm trying to catch you. What type of function is this? It's a rational function. Does my shortcut work? Shortcut does not. Okay, shortcut doesn't work. So I have to go back and do it the way we did it last year. All right, I would have to plug in the negative y's, I'd have to plug in the negative x's, and I had to do all that algebra stuff. All right, we're not going to do the algebra because we did it last year quite a bit. Okay, I believe if I did this correctly in my notes, then this one is symmetric around the origin. Okay, so if you would want to practice that later on your own, you could go back and try that just to see how you do that. Okay, so let's review horizontal. Oh wait, Dane.
Well, for the other one, the x, y, would that be a rational function too?
Yeah, it is, and it applied here, but in this form right here, I honestly would have to like do some research and Google that, because in that form right there, in that form, it looks like a polynomial curve, but then when I manipulate it, it becomes a rational curve, and it worked on this. All right, I don't think it works here. The shortcut rule doesn't work here because they're not all even or not all odd, because those are odd, those are even. That's odd, that's odd, that's even. That rule is not going to work, and I'm almost positive this is symmetric around the origin. But I do. Well, and when I wrote that, if you noticed, I paused a little bit when I wrote that down, and then I'm like, ooh, wait a minute. All right, but when I graph it, it is a fractional function. So I'll look that up because now I am curious. I'm going to look that up and then get back with you. Okay. All right. So, but like I said, are you going to do this a lot? No. Like in the curve sketching chapter, you know, you might want to use symmetry just to help with your curve sketching. Okay. All right, now let's do, we didn't necessarily like, or we didn't do a lot of our horizontal parabolas. All right, you were supposed to memorize them last year. Horizontal parabola. Okay, so we know they either open to the left or they open to the right, and those are very bad sketches right there. Okay, so horizontal parabolas, you're going to encounter actually quite a bit this year. Okay, so in standard form, let's just go back and do a little bit more than what we did with them last year. Okay, so in standard form, basically what happens is your X's and Y's are just inverted as to where they normally are. So it's going to look like X equals, and then an AY squared plus a BY plus a C. So we still have the, the squared and then to the first power and a constant. Your X and Y's are just switched from what we have so much worked with up to this point. Okay, so axis of symmetry. Okay, so axis of symmetry is still, axis of symmetry still uses the same coefficients. And in the vertical parabola, it's X equals. So in the horizontal one, it's going to be Y equals, but the formula is not going to change. Negative B over 2A. You don't need to memorize a new formula. You just need to know that if it's a horizontal parabola, my axis of symmetry will be a horizontal line. Okay. And then if we have a positive A, it's going to open to the right. And if we have a negative A, it's going to open to the left. Okay, and the way I remember that is because if it's opening to the right and it's a little Pac-Man, it's going to the right on number line, it's going to eat those positive numbers. If it opens to the left and it's moving along that thing, it's going to eat the negative numbers. So think of a little Pac-Man going. Okay, that's how I remember that. All right, and then if there's no Y term, the C is going to shift that vertex right or left. Okay, if there is no Y term here, okay, if that's not there, then this is going to shift right or left. Because when it's the other vertical parabola, and I don't have this term, it shifts up or down, right? So this is going to shift left or right. Okay, all right, so let's just kind of sketch one here. See what it looks like when we sketch. Let's do like X equals 4Y squared minus 3. All right, we sketched those last year. Hopefully you're still pretty good at that. Okay, the 4 is going to tell me what? Positive 4, so it's going to open to the right. I'm opening to the right, and then there's no Y term, so I did this one on purpose. There's no Y term there, so that negative 3 is going to tell me that it's going to shift to the left. Okay, so from that, that's all I need to get a nice little sketch here. I'm going to shift 3 to the left, 1, 2, 3. And then there's no shifting up or down or anything because it's not in vertex form or anything. And I said it opens to the right. So if I'm doing a sketch, really bad, rough sketch, there we go. And as long as you remember that from last year, you're pretty good. Okay. Now, we will have to do more complicated ones than that this year. All right, they might give them to you in that standard form. Okay, so let's do standard form. All right, let's suppose we've got an X equals a negative 2Y squared and then plus a 4Y plus a 1. Okay, so it's in standard form. Means you've got to do a little bit more work to find that axis of symmetry, okay, and to find maybe the point of the vertex. You're still going to look at this leading coefficient. It's a negative 2, so that's telling us what? We're going to open to the left. I don't know why I wrote in. We're going to open to the left. Okay, at this point, I would probably do my axis of symmetry, right? So y equals negative b, which would be negative 4 over 2 times a. 2 times negative 2. Don't let me make a mistake. Negative 4 over negative 4, so 1. So y equals 1 is going to be my axis of symmetry. Now, if we know where our vertex is, let's go ahead and find the actual coordinate. Okay, so what do I do with that y equals 1 if I want to find the ordered pair for that vertex? I take the 1 and put it back in the
Plug it
equation.
back into the equation for y and solve.
Yep, so I'm going to do 1, and we're going to do this in our head. So this is -2 plus 4, -2, or +2 plus 1 more is going to be 3. Okay, so I know that's my vertex. All right, now I'm still going to do a sketch. You remember the shortcut method that we did for parabolas last year? Okay, just because this is horizontal and not vertical, I can still do that same shortcut. All right, I've got my vertex. So let's go 1 and then 1, 2, 3. I don't have graph paper here, so this is not necessarily going to be really pretty.
Real quick.
Yep.
Wouldn't it be 3, 1 since y is equal to 1 and x is equal to 3?
Yes, you're right. Thank you, Josiah, for catching that. Because I did not catch that. 3, 1. All right, don't make that same mistake just like I did. All right, if it's a y, it's got to be in the y spot. Okay, so I'm going to get my white out at this point, because we don't want that little guy sitting right there. Okay, so now I wanted it 3, 1. There's my vertex, much better. Okay, so now, what was it? It was always we moved left or right 1, and then we multiplied by the magic numbers 1, 3, 5 with that coefficient, and then we went up. Well, this time, I'm going to move 1 up or down, and then when I do the 1, 3, 5, in this case, I'm going to be going to the left because I know I open left. All right, so let's do the 1, 3, 5 real quick. I'm going to show the multiplication here times my leading coefficient. So -2, -2, -2, -2, -6, -10. All right, which tells me to go left. All right, so I'm going to go, and like I said, not being on graph paper, it's not going to be real accurate here, but kind of. We're going to go up 1 and then to the left 2. All right, then we're going to go up 1 and then 6. So 1, 2, 3, 4, 5, 6. All right, now let's do it. I don't want to do 10. I'm going to run out of room here. So let's go down to the x-axis for my 1 and then up 2. 1, 2, or over 2. All right, down to the -1 and over 6. I'm going to put it roughly right about there. So while, yes, it's a sketch, it's a pretty darn accurate sketch when you do that shortcut. Okay, it's sad and pathetic when we draw it, but you get the idea. But I just wanted to show you that shortcut that we used still works on your horizontal. Okay. Okay. Are we good there? Don't figure we need to do a million of those. All right. Now, something that I know we did on our graphing calculators last year, I'm not sure that we did a whole lot of it by hand. Okay, so this year we'll probably, I mean, obviously you can use the graphing calculator, but not on our IU stuff. All right, let's take a look at finding points of intersection. And then let's actually say by hand. Because like I said, you can find points of intersection with your graphing calculator with no problem. Okay. Now, what's going to happen is they're going to give you 2 equations. Okay. Could be straight lines, could be parabolas, could be functions. We don't even know what they look like. So x squared plus y equals 6. Maybe for our first one, we know that one's just going to be a nice little parabola. All right. Or then maybe x plus a y equals a 4. Okay, so obviously we know that one's a straight line. Okay, so we've got a parabola here. All right, is that going to be right side up or upside down parabola? Be careful. It's going to be upside down, right? Because if I solve for y and I move this over here, I got a negative leading coefficient. So this is going to be an upside down parabola, and this is just going to be a straight line positive slope. All right, so obviously they're probably going to cross somewhere. Okay, this actually that's going to have a negative slope. If I wanted to be a little more precise, I can look at that right now and I can tell you it's going to have a negative slope. Okay, so they're probably, if I were to guess, it's going to probably look like something like this. All right, so in theory, then I should have 2 points of intersection, something here and then something here. Okay, now since these equations are in the form that they are in, what it's going to be easiest to do, probably, solve the top one for y, solve the bottom one for y, so they're both equal to y, and then I can set the two equal to each other. Okay, so let's take that top equation, x squared plus y equals 6. If I solve that for y, I'm going to subtract x squared, so y equals 6 minus x squared, and it really doesn't matter the format that you put that in. All right, let's take the other equation, the x plus the y equals 4. Let's solve for y on this one. Subtract x from both sides, y equals, again, I'm going to go 4 minus x. It really doesn't matter. Okay, so I have solved for y. Okay, now they both equal y, so I can take this and I can take this, and I can set them equal to each other and solve for x. So 6 minus x squared equals 4 minus x. All right, now, I would probably move everything to the right because I don't want a leading coefficient that's negative. So when I move everything to the right, then I'll have a 0 on the left-hand side. That'll become a positive x squared. Minus x is going to stay. Don't let me make a mistake. 4 minus 6, what, minus 2? And then we've got a nice little quadratic. All right, we're ultimately trying to solve for x. When we solve for x, we're going to have the x coordinates of those points of intersection. Okay, so this one's going to factor. If it doesn't factor, then you're going to have to do quadratic formula. Okay, but 2 and 1, it's going to factor really nice here. 2's got to be negative, 1's got to be positive. Again, don't let me screw this up. All right, x equals 2, x equals negative 1. All right, so my intersection points, all right, would be a 2, and then we got to figure out what the y is. And then we'd have to find the other one, plug in 1. Okay, so we're going to plug it in now. Technically, doesn't matter which equation I plug it into? No. Dane, you have a question? Oh, yes, I did. I forgot the little negative. Thank you very much. You got to catch me. I'm blaming it this year on the mask. Right? Yeah, there we go. All right. Doesn't matter which equation I plug it back into? It doesn't, right? Pick the simplest one. If I put a 2 in here, then that means this y is going to be 2. If I put negative 1 in, oh crap, I can't do that. It's going to be 5. Okay. All right. So I don't think I ever made you find points of intersection by hand last year. Okay. But conceptually, we did various, like in the graphing calculator, when you were trying to solve something that there was something on the left and something on the right side of that equal sign, you put things in the graphing calculator in y1 and y2, and then you found those intersection points. So you were finding a solution, so you were finding these in essence. Okay. All right, so I think we're good. Okay. A little bit still review, nothing too intense yet, even though it's chapter P. All right, it'll stay like this probably through chapter P. Honestly, I don't remember when it's going to happen. It might not happen until chapter 1, but we will start taking a look at some calculus concepts, all right, from a graphical standpoint, all right. So that's about the first time that we'll be encountering new material. All right, anybody have any questions? Okay, all right, definitely thank you to everyone that caught my mistakes this morning. That's what you need to do because I'm asleep sometimes. All right, if nobody's got any questions at home, I think we're good. I'm going to give everybody here in the room time to work on their assignments, and then we should be good, and I'll see you guys tomorrow.